Hello everyone, I'm Typhoon, and in this lecture we will begin implementing real-world LLM-powered application, a conversational chatbot that evolves from a simple query handler into a context-aware assistant. Now we will build it step by step from establishing a basic structure like we did in the previous lecture and expanding it with the memory features in this lecture. You will not only see the working code, but also learn how each component contributes to a better user experience. Now, before diving into advanced functionality like memory and tools, we first need to create a basic chatbot, like we did in our previous lecture. This initial version, often referred to as the plain vanilla bot, will serve as the foundation. It will answer a single query using a large language model. Now let's start by explaining what we did on our previous lecture. We imported the essential classes from LangChain's OpenAI and core modules. We set our OpenAI API key. So use environment variables in production environment. Remember that. Do not use it like that. We initialized the chat model with the API key. We defined the type of messages that the chatbot will handle. This is a system message which defines the assistant's behavior. We are telling the assistant that you are a helpful assistant that helps the user plan and optimize itinerary. And human message, I'm going to Turkey for 3 days. What can I visit? And the human message basically represents the user input. And here we invoking the model using the predefined messages and capture the response. Here response chat invoked message here. And lastly, we are printing the response content. In this code, we set up a basic conversational flow with a static query in previous lecture. While this chatbot responds accurately, let's try it again. This chatbot responds accurately. It does not remember previous inputs or hold any context beyond a single exchange. Next, we will expand this into a dynamic, context-aware conversation by integrating memory. And once the basic structure is in place, we can exchange our chat. By the way, you can download this code from the lecture attachment sections, or this is a short code, you can write it by self. And memory allows the assistant to maintain context across multiple turns in a conversation. This is crucial for building intelligent agents that engage in natural, human-like dialogue. Now for this lecture, we will use conversation buffer memory, a memory module that stores previous interactions as a plain text. Now this is ideal for short or moderately long conversation where chronological order is important. Now we will combine memory with the conversation chain, which links the LLM with the memory and handles conversation automatically. Here we will initialize and memory and conversation chain. So here from LangChain, LangChain.memory, import conversation buffer memory. And from LangChain.chains, import conversation chain. So we imported the memory and the conversation chain models. Let's actually try to run it. If we will have any problems with that, import here. Yeah, no problem at all. And now we will initialize the memory to store conversation history. Conversation buffer memory. Here we initialize the memory to store conversation history. And now in the conversation, we will combine memory with the LLM using conversation chain. So we will do it here. Conversation. Conversation chain. And here we will import one by one. First, LLM is going to be our language model, which we created here. So it's going to be chat. This is our language model. Verbose. So you may ask what this verbose is. I will explain it right away. So verbose basically prints the internal prompt formatting and debug info. So it will be helpful. And memory. Remember, we created some memory here in top. Let's actually delete this now. So memory, conversation buffer memory. So basically we'll give memory as memory. And that's it. This basically stores the chat history. So the verbose true flag is particularly useful for learning and debugging because it shows exactly how long chain builds prompts using memory. Now we will test the memory with the multiple interactions. Now let's send multiple queries to our assistant and see how it uses memory. So now we will comment it out for now, the response, this, yeah, we will comment it print 2, and here we will begin the conversation. We will begin the conversation dot run. Oops. Yeah, conversation dot run. First, he will say, "Hi there," and we will ask a follow-up travel-related question. Conversation dot run. We will ask, what is the most iconic place in Istanbul? And we will refer back to the previous answer without repeating the subject. Conversation.run. What kind of other events? And now let's run it. And here we are. Look at a nice output here. Now you can see the conversation buffer memory is deprecated in LangChain. Yeah, we will fix that too. So here we have the prompt after formatting. The following is a friendly conversation between human and an AI. AI is talkative and provides a lot of specific details from its context. If the AI does not know the answer to a question, it truthfully says it does not know. That's very helpful AI. Current conversation, hi there. AI, finished chain, entering name conversation, prompt after formatting. The following, so it says hi there, current conversation. AI says, hello, how can I help you today? Human says, what is the most iconic place in Istanbul? It finished the chain, entering new conversation chain. Again, it's the same prompt. And after that, hi there, hello, how can I help you? What is the most iconic place in Istanbul? The most iconic place in Istanbul is probably Hagia Sophia. It was built as a cathedral in the 6th century, later converted into a mosque, and now is a museum. Its stunning architecture and rich history make it must visit for anyone in Istanbul. What kind of other events? And AI finishes the chain. Now, even though we repeated the Istanbul or Turkey in the last query, the assistant understood the reference and responded kind of events in Istanbul and responded by with memory. Run it again. What kind of other events in Istanbul, and it finishes the chain. Previously it said 16th century and now it says 15th century. So this function is particularly helpful. Also we have something here. So also LangChain allows you to manually inspect the stored conversation history. So how you can do that is, after memory, you can say that memory that load memory variables, and here we are. Here and here as well. And now we'll get the stored variables. Now, this is helpful for debugging or analyzing how the assistant uses memory to formulate answers. And now we will create an interactive terminal chatbot. Now let's build an interactive loop where users can freely and quit when they choose. And this simulates a real chatbot experience. So we will make it smaller. Let's actually run this here. Now, while true, so it will basically always true, query input you. So this will get user's message if the query that lower equals to q. If the query, if the user will type q, it will quit. And after that, we will break the while loop. And here we will have the output. Output is going to be conversation. Input here. Query. And after that, we will print the user query here as well. And again, we will print the AI system 2. AI system. Output. Oops. Output and here response. Now we will print. We're printing the bot's reply. And this loop, hello there, how can I assist you today? Tell me best places, best historical places to travel in Tbilisi. You can see it's told us the historical places in Tbilisi. Now this loop continuously accepts user inputs and provides responses, all while keeping track of the conversation through the memory module. So how many places you told me in previous conversation. And here we are. I mentioned 5 historical places to visit in, and that's good. Yeah. So which one? Let's actually ask another. Which one is closer to Narikala fortress? Siona Cathedral is the closest historical site to Narikala. It is located in the old town area of Tbilisi, not far from the fortress itself. Yeah, let's make it harder and calculate the estimated distance by kilometers. .2 kilometers. Yeah, that's it. Now notice how the assistant retains relevant context, allowing for smooth and meaningful follow-up questions. Now this ability to recall the answers and build on them is what gives conversational AI its realistic and engaging quality. Now that's it with our lecture. Thank you for watching, and I'm waiting you in next lecture.